everybody to my class, and today we will be talking about exponents. Okay, this is our second class on exponents. Uh, and let me introduce our schedule first. So first we're going to be doing a review of last class. There are quite a few new students today, so if you do not understand the material here, don't worry, I will review the material from last class to clear your understanding of exponents, okay? And next we'll be learning about scientific notation, okay? I know some of you are wondering why I'm teaching scientific notation right now. Why? Because we are doing exponent related stuff. I know I already taught scientific notation when I was talking about number theory, but we'll be doing much more complicated problems with scientific notation. And lastly, we will be doing rational exponents, okay? So, are there any questions about our schedule? Any questions about our schedule? Are there any technical difficulties? You can't hear me or something like that? Are there any questions? No questions? Then I will continue. So first we're going to start with the review, of course. So what is the definition of an exponent? So an exponent is a mathematical operation. It's usually written as b to the nth power, okay, involving two numbers, the base b and the exponent or power n, okay. Remember, base, okay. The base is very important, okay? And I'll talk about that when we're talking about properties of exponents later. So let's review. Exponents, okay, are repeated multiplication, okay? In this example demonstrates that, okay? So 2 to the 4th power is basically 2 times itself 4 times, okay? And that equals 16. Now this is very basic. I hope most of you know what an exponent is already, so I don't need to go over this a lot. So let's just start with an easy one. What is 5 to the 3rd? Okay, what is 5 cubed? Okay, should be a pretty quick answer. So please put your answer in the chat. This will serve as a warm-up question, I guess. Very good. We have a lot of answers. Okay, 125. Jason, 1,125. I hope that was a typo, but you did give me the correct answer after. Okay, and our new students are also responding as well. Very good, very good. Okay, it's going to be 5 times itself 3 times, okay? This should be very easy after I just explained everything. Okay, now let's go over some negative and zero exponents. So can our new students tell me what a negative exponent is? I want to see if your understanding of exponents is very high. If you do understand exponents, then hopefully I won't be able to stay in this review very long. Then we can actually go on to scientific notation and rational exponents. So can anybody explain negative and zero exponents? If no one knows, then I'll have to review it. I taught you this in our last class, so hopefully some of you will know what a negative exponent is. Okay, I'll give you a moment. Reza, 9 to the power 0 is 1, exactly. Anything to the power of 0 is 1. Okay? And let me prove that, okay? So you need to understand why it works, not just knowing that this works, okay? That is very important. You need to understand why it works. Okay? So what is 2 to the third? Yes, this example again. 2 to the third is 2 times 2 times 2 equals 8. What is 2 to the 2 squared? Okay. 2 times 2, right, equals 4. And what is the relationship here? Okay, you divide by 2. Okay? 2 to the first power equals just 2. What is the relationship? Another divide by 2. Okay? So the relationship between these powers, you go down in power, okay, you divide by the base. And right here is the base. Okay? Remember, b to the n, this is the exponent, this is the base. Make sure you understand that. So let me go on with proving why the zero exponent is always 1. Now we're down to the first power, right? It's going to be 2. So every time you go down a power, you divide by 2. Now let's go to 2 to the 0th power. What is that? You might think it's 0, but does that make sense? It is not, because what is 2 divided by 2? It's going to be 1, right? It's going to be 1. And let's prove this again. Let's use 3 this time. So 3 to the third, that's going to be 27. 3 to the second, that's going to be 9. Okay, divide by the base, right? What is the base? It's going to be 3. You divide by the base. Okay, every time. And 3 to the first is going to be 3. And 3 to the 0th, divide by the base. It's still going to be 1. Okay, so that is how you prove that anything to the 0th power equals 1. So that is basically 0 exponents. Okay, and now I want to go over negative exponents. But first, let me ask, are there any questions whatsoever? Any questions? Yes. Are there any questions? Anyone? And I see some new people have joined. Okay, very good. And maybe you joined late and you missed something, then you can just tell me what you missed and I'll just go over again. Okay? So, any questions? No questions? Okay. So, now let's go over negative exponents. So, let's just let me erase this example with a 3. It's going to keep this 2 example. So, first let me introduce the formula for negative exponents. So, a, which would be the base, okay, to the negative n, and n is going to be the exponent, okay, equals 1 over a to the n. Okay, so anything to a negative exponent is going to be 1 over that base to a positive n. And let me prove that. So let's keep going, okay. 2 to the negative first power equals, what is 1 divided by 2? 1/2, right? And right here, 2 is the base, right? So 2 to the negative first power, okay, that I wrote a for some reason. 2 to the negative first power is going to be equal to 1 over 2 to the first power, and that's going to be 1/2, okay? And let's keep going. 2 to the negative second power is going to be equal to 1/4, right? That's 1 over 2 to the positive 2. 1/4, okay? So those are basically negative and 0 exponents. exponents. Okay, Jason, I hope that is a nope for no questions, right? Good. So, actually, before we move on to our review problems, I want to review another thing. So I hope you all remember the properties I introduced last time. The properties. Okay, remember there are three properties for three multiplication properties for exponents and three division properties for exponents. So I hope you remember those. And I'll give you a challenge. For those who have been to my last class, I hope you remembered those properties, and if you can, type them in the chat if you can. So there are three multiplication properties. And new students, if you don't know these, it's okay. You haven't been to my last class. So three multiplication properties. If you can post them in the chat. That'd be a bonus. Okay? And three division properties. And it might be a good idea if you don't know these, you should probably take notes on this because these properties are pretty important. Okay? So, let me go over the multiplication properties. Okay? Multiplication properties. First of all, okay, when you multiply exponents, multiplying exponents, you're going to add those exponents, and this is where the base comes in comes in handy. Okay, the base. It always has to be the same base if you want to use these properties on. Okay, so what is 2 to the second times 2 to the third? And it's going to be 2 to the fifth. Okay, what did I do here? I added these exponents. Okay, I added these exponents, but make sure they are the same base. Okay, these have to be the same base. Okay, so our next multiplication exponent. Does anybody want to take notes? Okay, Reza. Commutative property, associative property, and distributive property. Well, yes, those are properties. Well, yes, those are properties, but we are going to be talking about the properties of exponents, okay? Those have nothing to do with the exponents. But you are right, those three are very important properties. Okay, we use distributive property a lot in algebra, but those aren't exponent properties. Let me now introduce the second property. Okay, our second property is power to a power. Okay, power to a power. And please excuse the bad handwriting. I used to have pretty good handwriting, and then I started typing, and yes, my handwriting went downhill pretty quick. So power to a power, 2 to the third to the fourth power. Okay, and what is that? So that's basically 2 to the third times 2 to the third times 2 to the third times 2 to the third. And what do you do when we have these multiplication, okay? A multiplication property, that first one that I just told you, this comes in handy. So see, you multiply these exponents and you just add these exponents, okay? Because they have the same base, Okay, so that's going to be equal to 2 to the 12th power. And you see what I did here? I just multiplied these two. I multiplied these two. And let me give it another example. 3 to the 4th. The fifth is just basically going to be 3 to the 20th power. Okay? So that is power to a power. And if you don't want to take notes on these are actually pretty easy to remember. So, you don't have to take notes on everything. So, let me go on to our next multiplication property, and this is going to be our last one. Product to a power. Product to power. Okay, and this is like 2x to the 4th. So, first in parentheses, you multiply 2 and x, and then you take that to the 4th power. Now, when you do this, you have to raise everything in the parentheses to the exponent. So 1 is 2 to the 4th power. It's going to be 16. What is x to the 4th power? It's going to be x to the 4th. Okay? So raise everything to the 4th power. Are there any questions on these properties? These multiplication properties? If there aren't any questions, then I'll move on to the division properties. So our division properties, right? Our division properties, we have, dividing powers. Remember, we had multiplying powers, dividing powers now. And again, please excuse this horrible handwriting. Dividing powers. Okay, so when you divide powers, you subtract them. And this, of course, only works on the same base. So 2 to the 5th over 2 to the 3rd equals 2 to the 2nd. Okay, see what I did here? It's basically 2 to the 5th, 2 to the 5 minus 3 power. Okay, you subtract the exponents. Okay, subtract the exponents when you're dividing. Okay, of the same base. Okay, you have to subtract the exponents. So let's try another one. 3 to the 4th over 3 to the negative 2nd power. What is that? And I'll give you a few moments to put your answer in the chat. And since we are going pretty slow on this review, I might have to go over time today, so please excuse that as well. So please put your answer in the chat. 3 to the 4th power over 3 to the negative 2nd power. Very good. 3 to the 6th power. Congratulations, that is correct. And it is very concerning that no one else gave me an answer. Very concerning indeed. Anyways, so what is this? 3 to the 4 minus negative 2, okay? That is going to be 3 to the 6th, obviously. So our next division property, our next division property is going to be quotient to a power. Okay, quotient to a power. So, quotient to a power is basically, what is this? Quotient to a power is basically x over 4. That's going to be a quotient, okay? So when you're dividing something, it could be 2x over 4, something like that. And then you raise that to a power, okay? And my numbers are pretty horrible as well. Please excuse the bad handwriting. I don't know why I got bad handwriting, but yes. Anyways, so remember, what did we do? To product to power, okay? You raise everything in the parentheses, okay? And this is the same thing. Quotient to the power, raise everything in the parentheses to the power, okay? So 4 to the 5th, and I don't have that the top of my mind, so I need to use my calculator. 4 to the 5th, wow. That's going to be 1,024, okay? So that is going to be our answer. Remember, raise everything in the parentheses to that power. Okay, our last one is quotient to a negative power. That's going to be the same thing that we just did, but to a negative power. And this actually has a pretty neat trick to it. So let's use the same example. So actually, let's make it squared this time. X over 4 squared, negative squared, to the negative second power. Okay, what is that? That is going to be 4 over x to the second power. And see what we did here? We flipped everything in the parentheses. So when you have a negative power, and you can try to prove this on your own. Okay, we're running out of time, so I'm not going to prove it, but it is pretty easy to prove. So you just flip everything in the parentheses and raise it up to the positive exponent, okay? And that would be 16 over x. Or there's another method, okay? So you can just solve it while it's flipped. Okay, solve this, okay? Solve this. And take out the negative, okay? And then once you're done, you can flip it. Basically the same process. I don't care how you do it. You will get the same answer. Anyways, let's move on to some review problems. Okay? I'll give you a few moments on this one. And this uses some of our properties that we just went over. I'll give you a few moments to try and answer this. Okay. So when you have an answer for this, you can just put it in the chat box. No answers. Very concerning indeed. Okay, Reza, a to the negative first power and b to the fourth power. What did I say in our last class? When you simplify an exponent, do not leave any negatives. Yes, Reza, your answer is equal to the correct answer. However, it is not simplified fully. So let me do it. Okay, let's just section off our variables here. Basically this. Why did I put a 6 there? That's very concerning indeed. Anyways, A to the negative third over a to the a to the second. Okay, Reza, your answer is wrong. Why? Because you are supposed to subtract the exponents rather than add them. That's what I just said. One of the yeah, it was a division property. Okay, remember, subtract our exponents. Basically, this is going to be a to the negative fifth power times b to the fourth. And what do you do with negative exponents? It's going to be 1 over a to the fifth times b to the fourth. It's going to be b to the fourth over a to the fifth. That's our answer, okay? Very good. 4166. Very good. Very good. Anyways, does anybody have any questions? Okay, no questions. So let's go on to this next problem. Actually, this problem, this is too easy. Let's just skip this one. I'll just tell you the answer. So let's just section this off. When you see problems with this, spot this zero exponent. It's always going to be 1. Okay, no matter what crazy things are going on, it's going to be 1. Okay, so the A section is going to be 1. What about the B section? Okay, B. Okay, negative 3 times 3 is going to be negative 9 times 1. It's going to be 1 over b to the 9th. Very easy. Should have been pretty quick. So now let's finally move on to scientific notation. So a times 10 to the nth power is going to be scientific notation. Okay, note that a is between, okay, so 1 is less than or equal to a. Okay, so a can be 1. However, a must be less than 10. Okay, and n is an integer. Okay, can't be a decimal, can't be a fraction. And negative exponents are allowed. Remember when I said to Reza, okay, when you simplify, there shouldn't be any negative exponents. Okay, there shouldn't be any negative exponents. But in scientific notation, negative exponents are allowed. So let me show you what scientific notation does. And this is scientific notation is how we take note of numbers that are really, really, really big or really, really, really small. Okay, so let's take 6. 6 times 10 to the fourth. What is that? Okay, and actually, let me just include that in the examples section. So our examples. So let's start with 2.87. Okay, that is going to be greater or equal than 1 and less than 10. Okay, so yes, that is good. 2.87, and remember these can be a doesn't have to be an integer, so it can be a decimal. And times 10 to the 6th. And what is that? So let's just take this decimal 2.87 first. 2.87. And what we're really doing with this, okay, we are basically moving the decimal point, okay? So we take this decimal point, and when we multiply 10 to the 6th power, and you take notice that 6 is positive, so when you do that, you have to move the decimal point to the right. Okay, so 1, 2, 3, 4, 5, 6. That is going to be our answer. It's going to be 2,870,000. Okay, As I said, scientific notation is going to be used for numbers that are very large. Okay, let's say you had 2.87 times 10 to the first. What's the point of that? You can basically just write 28.7. Okay, you do not need to put it into scientific notation. So please be reasonable when you're using scientific notation because it's used to denote numbers that are super big or super small. Now, let me show you the super small portion of this, okay? And that is when we have negative exponents. Same example, but 6 is negative. Let's still take this decimal, actually, I shouldn't put it there. Let's just put it over here. Okay, 2.87, and what do? We actually move the decimal point, but instead of going right, we are going left, okay? 1, 2, 3, 4, 5, 6. And that is how we do it. And our decimal point is right here. Okay? 0.0000287. See, that is a very small number. So, as I said, scientific notation is for small numbers or big numbers. Okay, so does everybody get what scientific notation is right now? Are there any questions? Yes, Jason, very good. So, whose comment is this? Jason. Okay. No question. Very good. So now we know what basically scientific notation is. Now we know what scientific notation is. Let's go deeper into scientific notation. And I taught this in my number theory lesson, so you should all know this already. Now it's just refreshing your memory. Now let's go into multiplying scientific notation. Okay? And there's also dividing scientific notation. Okay, so there's only one type of multiplying in scientific notation, but there's two types of dividing, I think. Oh, is it two types of? Yeah, there's two types of, actually, there's only one type of dividing, but two types of multiplying. And I'll elaborate later, okay, on this. So now let's go to multiply scientific notation. So, what do we do with it? Okay, so let's say, what is a good number? 3.48 maybe, okay, times 10 to the third, okay? Put that in parentheses. And 9.8 maybe, okay, times 10 to the fourth, okay? That should be a pretty good example. And what do we do here? Okay, so when we multiply scientific notation, you multiply the like terms. Numerals, multiply numerals. Exponents, multiply exponents. Okay? And actually, I'll erase this so we have more workspace. Okay. So what is 3.48 times 9.8? Okay, get out your calculators. 3.48 times 9.8 is going to be equal to 34.104 times, okay, what is 10 to the third times 10 to the fourth? 10 to the seventh. Okay, moving on. Wait, no. Why are we moving on? Because, remember, A has to be greater than or equal to 1 and less than 10. So what do we have here? What is wrong here? Can anybody tell me the mistake here? It's on A right here. Okay, the mistake is on A. It's 34.104. Okay, that's greater than 10. We can't have that. So actually, what we can do here is we can move our decimal point. Let's move it. It's going to be 3.4104. And if we move our decimal point to the left, okay, we move it to the left, then we have to add 1 to our exponent here. Okay, if we move our decimal point to the left, we have to add 1 to our exponent. So let's go over the other type of multiplying scientific notation. What is that? That is going to be, remember that multiplication property we talked about? Yep, that's what we're going to be doing right here. So, it's basically 6 times 10 to the negative 5th to the 3rd power. And remember, multiply everything in the parentheses. So what is 6 to the 3rd? 216 times, okay, 10 to the negative 15. And you don't need to simplify this because, as I said, negative exponents are okay. So, we're done, right? No, we are not. Look at this. 216. That is a very big number, and that is way more than 10. So, what do? Our decimal point is right here. We move it. We're moving our decimal point to the left. And remember, to the left, we are going to be adding, okay, to our exponent. And how many places did we move? We moved 2 places, okay? So we add 2 to our exponent. It's going to be negative 13. And this answer is going to be 2.16 times 10 to the negative 13. Now, let's go to dividing. But before we go to dividing, I just want to ask if you have any questions. If you have any questions, please put them in the chat. Hopefully no one has questions. We are already running pretty late. Okay. A question from school that requires scientific notation. Okay. Okay, see? Okay, you can give me the problem. Whoa. So, what is the value of 4 to the 12 times 105 to the 7th? Okay, that is certainly an extremely big number. Yes. Okay. Yeah, that is pretty big. So you do have to express it in scientific notation. So what is the value of 4 to the 12th times 105 to the 7th? Now, what do? Okay? Basically, you're going to multiply these things. 4 to the 12th times 125 to the 7th. You multiply them, and you're going to you're going to see a pretty big number. Okay, you're going to see a pretty big number. Now, let's say, okay, let me just, this has nothing to do with the problem. Let me just give you a random number, okay? Let's say you multiply those and you get something, okay, something like this. Just right, there's so many sevens and eights. But anyways, you get a pretty big number, okay? You get this, okay? And you're probably not going to get that, but you get a really big number, and I suggest you use a Google calculator because normal calculators can't solve that. They only go to 10 digits. But anyways, you get this really big number, okay? And you need to do scientific notation on that. So right here, you have this decimal point that's right here, okay? And you're basically going to backtrack scientific notation. You're going to backtrack scientific notation, so you need to count how many places there are, okay? So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I think that's 11 spaces. I don't know really. Might be 12. Anyways, you get this 5.67, something like that. You're probably going to round it, times 10 to the 11th, right? That is what you're going to get in scientific notation, and that is my way to solve it. So, well, we really are late. Anyways, if you do have any more questions, Kaixi can stay back after class to ask them. So, did my way of solving it clear up everything? Are there any other questions? If no, then I'll go on to this dividing. This dividing scientific notation. Okay, so 1.6 times 10 to the 6th over 4 times 10 to the 2nd. And that is going to be equal, okay, remember, divide like terms. So, it's going to be 0.4 times 10 to the 4th, right? So 1.6 over 4 is going to be 0.4. And you're going to subtract the exponents for the 10. Okay. So, is this okay? No, it is not. Why? Because 0.4 is less than 1. So, what do you do here? It's too small. This time we're going to move to the right. And you guessed it, to the left we add 1 to the exponent. And if you go to the right, you're going to subtract 1. So right here it's going to be 4 times 10 to the 3rd. Oh. Okay, we are running late. Anyways, let me just go over rational exponents now. Are there any questions on anything that just happened? No one has questions. Very good. So, a to the 1 over 9th over nth power equals a to the nth root. And that is basically what we are going to be learning in rational exponents. Now, rational exponents are basically fraction exponents. So let's say 3 to the 1/3, okay? So we have this formula right here. A to the 1 over nth power is equal to a to the nth root. and to the nth root, that is basically, okay, and let me explain that, what the nth root is. So usually we have square roots, right? Square roots, what is the square root of 144? That's going to be 12. Now, let me introduce other roots, okay? Other than square roots, we have other roots, okay? We have, let's say, cube roots. We have fourth roots, okay? 27. What is the cube root of 27? That is going to be 3. Because 3 cubed equals 27. So the cube root of 27 is going to be 3. Now, what is the fourth root of 16? That is going to be 2, because 2 to the fourth equals 16. Okay? So that is our formula. Now, we have been dealing with fractions with 1 as the numerator, okay? 1 on top. But what if we have 3 to the 2/3 power? What if we have 3 to the 2/3 power? Okay, if we have 3 to the 2/3 power, we use this formula. This formula, okay, a to the m over 9th power equals, okay, a to the mth power, okay, to the nth root. Okay, that's a tongue twister. So let me do it here. So basically, let's use this example. A is going to be 3. Okay, A is going to be 3, and m is going to be what's on top. So 3 squared, cube rooted. Okay, does that make sense? Are there any questions on these formulas? Any questions? No one? No comments? Okay. Then I will continue. So sometimes you get something like this. What if you have 25 to the 9/4 power? Okay. So what if you get this? Okay. That's gonna be this. And 25 to the 9th power. That is an extremely large number. Okay? And then you have to take that to the 4th root, which isn't easy either. So what I advise you to do, instead of using this exact formula, yes, it does look good and looks professional and stuff, but more easier way to do this is going to be doing this. Okay. So first you take 25 to the 4th root. Put that in parentheses. Then after you take the 4th root, it's going to be a pretty small number, right? And a small number, then you take that to the 9th. Okay, so a small number to the 9th is still pretty small. It won't be pretty big. So first take a root, get a smaller number, and then take it to the larger exponent. Okay. But if you want to use the other way, you can, and that's usually for our smaller fractions, smaller numbers. Okay. So moving on, radical form. Let me just okay. Let me go over radical form first. Okay. So basically, we learned about exponential form. Exponential form. So exponential form was that exponential form is going to be b to the n. B to the nth power. And radical form, usually there's a square root, okay? Radical form is going to be something like this, okay? Square root of b. Okay, so this is going to be our exponent form, exponential form when we are doing rational exponents. Okay, fraction exponents basically. This is going to be the exponential form. So if your teacher or an exam asks for exponential form, this is going to be it. And usually they ask you to stay in exponential form. Why? Because let's say 25 to the ninth. Okay, you're obviously, if you multiply that out, that's going to be extremely large number. Okay, so usually they just ask you to just stay in exponential form. And if you can simplify it to radical form, you probably will. Okay, so remember, b to the 1 over nth power is going to be square root of no, it's going to be b to the nth root. Okay, so that is basically radical form. It's not too hard. And examples. I need to think of some on the spot. But actually, let me do. So let me introduce what you do if you have. Okay, what do you do if you have? So let's say we have two terms here. Actually, we have two terms here. Okay, so basically, yeah. So when we have two terms here, okay, what we're going to do is let's do this. This is what you're going to do. You're multiplying these two terms, okay? Okay, this is what you're going to do basically. So, we're running out of time, so let me just quickly go on to another example. So 32a, okay. So what else? Let me think of something. 4 or 4 over 5. Okay, what is that going to be? So that's going to be basically just okay. Here, remember, raise everything in the parentheses to that power. Okay. So we also have this. Okay, we're done here. So we raised both of the terms, numerals and the variables, okay, to that 4 over 5 power. Okay. So that is going to be, and 32 to the 5th power is going to be 2, and 2 to the 4th power is going to be 16. 16 times this. Okay, that's basically a to the 4th to the 5th root. Okay, so now let's do some practice problems. And these are going to be involving both radical form, rational exponents, and scientific notation. Okay. So our first problem here, I'll give you a few moments to solve this. This should be pretty easy. This is involving scientific notation, and our next problem will be harder. I'll give you a few moments to solve this. 7/1000. And Kaixi says 0.007. Uh, that is very likely. Probably you, I think you simplified it into actually standard form. Okay, very good. Everybody is putting it into standard form. And I also accept if you actually leave it. And if you actually leave it to scientific notation, that's fine as well. You don't have to simplify it. But let me solve it now. Okay, so basically 4.2/6. What is that? Calculator out. 4.2/6. 0.7 times 10 to the negative second. Yeah, that is 0. Wait, no, that is not it. 2 zeros. Okay, so that is going to be 0.007. Yes, that is 0.007. Very good. Now our next one. This should be pretty hard. Okay. And round your answers. Okay? Round your answers. And once you're in the process of it, okay, don't round. Don't round your answers in the process of it. Okay, round your final answer. That's what usually you're going to do on some exams. Okay, round your final answer to cents. Okay, round to the nearest hundreds. Okay, I'll give you a few moments to solve this. Put your answer in the chat box. So, a company that manufactures memory chips for digital cameras uses the formula C equals 118 times n squared to the cube root plus 1269 to determine the cost C in dollars of producing n chips. So how much will it cost to produce 222 chips? Okay, I'm going to use the restroom now. I'll keep working on this question, and I'll check the chat box and keep working. Okay, I'm back. No answers? Okay, then I'll walk you through it. So basically, this company that manufactures memory chips for digital cameras uses the formula C equals 118 times, okay, whatever mess that is. So Of course, how many chips are we producing this time? 222, right? Let's sub that in. Okay, that is what we are going to be doing. Actually, let's use the other method. It's going to be easy. So, and then after we're done with that, we add 1269. Actually, this shouldn't be too hard, actually. It's just basic computation. So, let's do 222 to the cube root. Okay, if you can, what the heck? The calculator doesn't have this cube root button, so apparently I'm gonna have to use Google for this one. What is this? Calculator. Cube root. What is it? Wow. This is sad. Cube root of 222. Okay, it's gonna be, wow. That's a very big number. Okay, so let's continue actually using this calculator. Let's go back. So back to our equation here. After we have our cube root, we're going to square that. So squared. Where's the squared button? Right here. Equals 36.6636177446. Yeah. So after we're done with that, we multiply by 118. Multiply 118. Okay? And that equals something like that. And after we're done with that, add. What is it? Add what? 1,269. That is going to be equal to 50, what? $5,595. 0.31 if you need to round it. And I forgot that. I think it was that? Yeah, it was. So, that is going to be our answer. It's a simple computation. Okay. Okay. And Jason, you go to math. Okay, apparently I don't know how to use the calculator. Jason is the expert here, and maybe my calculator doesn't have that option. But anyways, thank you for the tip again. Oh, and this will be our answer, and that is going to be our last question for today. Okay, thank you for listening, everyone. And like this video and subscribe to my channel. Why do I say this every time? And thank you for listening.